Statistical models can help your business to run more smoothly. For example, they can tell you as soon as a lead arrives the probability of closing a deal with that lead in function of the data you have collected about them. In other cases, statistical models can help predict future prices of raw materials that you use so that you can optimize your costs. The problem is that deploying statistical models on the cloud has its own problems, and deploying statistical models locally or on-premise, that means one server inside your company, has other problems, but in my personal opinion, it is easier. Here you see how I made a statistical model consumable by the final user, that is, having a prediction on what, in this case, the inflation of Italy with a model that sucks in terms of performance, but this is not a video on how to build good models on inflation. You see that we have our value for inflation, and the problem is that this value doesn't tell you nothing, because first you don't know which kind of, let's call it, default value I have for the inflation of Italy. If we expand these columns, first we see that the model I imported with this function returns a text, and that is of course a problem. Then with this transformation I have the actual value I want. Consider that the default value is 100. That is the reason why I told you this model sucks. Predicting the inflation can help you to, for example, stock raw materials in times and optimize costs. Of course, you understand that behind this link there is a word, and also behind this custom function, but the word is more behind this link because the rest is more or less easy to understand. And if we go to this link, we see the graphical user interface for our statistical model. Here we interact with it functionally with the Google Sheets functions, or also Excel if you want. If we go inside here and we click predict, we can try it out, and I will put 90 for fuels and this one for salaries. And let's say that if you have this value, you could expect a higher inflation, and if you have this value, you could expect less inflation. So minus and minus at the end should give a value higher than 100. And if we execute it, we see that we get what we got here, that transformed, it is this one. I say transformed because when building the model, I applied a transformation on the inflation value. So you can say that this one is our front end, and that is one part of our back end, one part. Because this model comes from a script, especially an R script, that you can see here. You see that the model comes from here, that comes from this file, and here we basically use this library of R to build the prediction. If we go to search this inside here, we see that the model is built with basically this variable, that means fuels and salaries. And if we search this, we see that the inflation target variable is built with a transformation that is basically our inflation to the -2, because in this case that was the best solution, even though the final model sucks. But now you could wonder, yes, how could you run this perpetually so that we have this accessible to the internet with this model? And that comes another part of the backend that is, if you want, the most complicated one. But in this video you will see that it is not so complicated, especially compared to the cloud, where, I want to underline it again, you have other difficulties. One option is I can execute this code as a background job. You see that I have no background job, because of course it is not a good practice to execute a code inside an environment where you write code. If I log in into the machine or server I use to deploy my service, we can see where the service lives and how I created it. If I paste this code that basically indicates an editor for editing the service I created, you saw this file that instructs the server on how to launch this service. This looks nerdy, I understand. The cloud surely has a more modern interface for that. But as I said, it is the easiest way because I'm showing you the steps for culture. So here we see the file to have the service. Then we have this, but of course it will have no difference in my case. And the explanation of this command goes beyond the purpose of this video. Then we have this where you notice the text enable. If we launch this, of course, no actual response because we have already active. And notice that enable and start in Ubuntu means something different. Again, start no response because I have it active, but this instead will give us something as output. You see, it is active and it is running at this URL, and you notice that here I have another URL because that is yet another part of the back end. So let me do a quick summary. This is the front end. This is, we can call it another front end that shows something of the back end. This is the actual back end of the code. This is where the actual model for the backend comes from, and this is the machine level backend. And in this part we have the networking backend that connects a local link to this public link that in this case can't lead to abuse because of the function of the code. And for the networking part I used Cloudflare tunnel. You understand that the tunnel connects at one end of the tunnel this, that is something local on the server side, to the other end, that is this, that is something publicly accessible because I didn't put a specific rule for who can access that URL. So we can say that the networking backend in this video looks a bit more abstract. And I also think you can now understand why when I say that with enterprise statistics you don't have a single data scientist but an entire department, because you saw with your own eyes that we had 5 components or skills that you hardly can find in a single person, except in the case they have a very high level of seniority. Because you saw a spreadsheet that works as a front end, that means a familiar interface for consuming, in this case, a statistical model. You saw the part of the back end that involves the construction of the weighter of the data, in this case the model, and the model that stands under the hood of the API or weighter of the data. You saw the machine level backend 4 that involves system administration on Ubuntu. And then you saw the network level backend that involves Cloudflare tunnel for connecting from the localhost to a publicly accessible URL. You see, 5 different skills. Sometimes you get 3 in a person, sometimes you get 2. It is very difficult to find 5 in a single person, unless you outsource it, of course, to a company. If you think you need a statistical worker like that, we can first discuss your case in a first free call you can book in the description. Bye, and see you the next time. Take you some time to digest what you saw, because I understand that I told about 5 components and showed 4, so there is much to elaborate.